Good day. I am GALAGAR. I'll be assigned to tackle the topic of traditional approach. The traditional method uses a linear approach where the stages of the software development process must be completed in a sequential order. This means that a stage must be completed before the next one begins. In traditional approach, these methodologies include the waterfall, V-model, rational unified process, and others. According to Matkovic and Tombas, these methodologies are based on the system development principles that have served as a foundation for the creation of the system's development, the date which can be either sequential or iterative. So, a few of us have questions to our minds that what is sequential approach? Sequential approach means that the methodology is made up of series of steps or stages that follow each other sequentially. The first example in traditional approach is the waterfall model. Waterfall model is an example of a sequential model. In this model, the software of development activity is divided into different phases, and each phase consists of a series of tasks and different objectives. There are five stages of the waterfall model: the requirement analysis, design phase, implementation or development phase, testing phase, maintenance phase. Requirement analysis in waterfall development of one phase starts only when the previous phase is complete. First, requirement analysis. During the first phase, the requirements for the system are established. Vision is defined as a long-term strategic concept of the ultimate purpose and form of a new system. Second, design phase. This phase largely covers such components as a programming language, data layers, service, etc. 3. Implementation or development phase. The actual source code is finally written in the third phase, implementing all models, business logic, and service integrations that were specified in the prior steps. 4. Testing phase. After the development phase, the product should experience a thorough quality assurance and software testing to discover defects in a system. Testers are involved in finding and reporting issues that need to be resolved. To store registered issues, a bug tracking system can be utilized with the goal that the issues could be handled during the maintenance and life cycle phase. 5. Maintenance phase. The maintenance phase engages not just the deployment of the software, but also support and maintenance that may be required to keep it functional and up to date. Still, like any other software development lifecycle model, waterfall has its strong and weak sides. So this model can suit every conceivable sort of a software project. To sum up, there's a table of the waterfall models pros and cons. So this is the advantage and disadvantage of waterfalls. Next is the V model. The V model is an SDLC model where execution of processes happens in a sequential manner in a V shape. It is also known as verification and validation model. And also the V model is an extension of the waterfall model and is based on the association of a testing phase for each correct corresponding development stage. This is a highly disciplined model, and the next phase starts only after completion of the previous phase. As you can see, this is the V model. The V model design. There are 5 verification phases in V model. The business requirement analysis, number 1. So this is the first phase in the development cycle where the product requirements are understood from the customer's perspective. Number 2, system design. The system design will have the understanding and detailing the complete hardware and communication setup for the product under development. Number 3, architectural design. So architectural design specifications are understood and designed in this phase. Number 4, module design. In this phase, the detailed internal design for all the system modules is specified, referred to as low-level design or LLD. Number 5, coding phase. The actual coding of the system modules design in the design phase is taken up in the coding phase. And there are 4 validation phases in V model. So first, unit testing. Unit testing is the testing at code level and helps eliminate bugs at early stage. Though all defects cannot be uncovered by unit testing. Number 2, integration testing. Integration tests are performed to test the quick systems and communication of the internal modules within the system. Number 3, system testing. System tests check the entire system functionality and the communication of the system under development with external systems. Number 4, the last, acceptance testing. Acceptance testing is associated with the business requirement analysis phase and involves testing the product in user environment. So the V model has advantage and disadvantages. This is the disadvantage and advantages of the V model. The advantages of the V model method is that it is very easy to understand and apply. The simplicity of this model also make it easier to manage. And the disadvantages is that the model is not flexible to change, and just in case there is requirements change, and also it becomes very expensive to make the change. So question is, why is the traditional method being applied? So because any organization that needs to develop a system may use traditional system development methods, and it is built in such a way that the programmer cannot move on to the next step if the step prior to that is not yet completed. How is the traditional approach used? Hmm. So, the whole process of software development, according to the traditional methods, begins with the understanding of the requirements and expectations of the customers or end user. Furthermore, systems development undergoes a sequence of some fundamental stages, such as planning, analysis, design, and implementation. So, who uses the traditional approach? People who use the traditional methods are known as IT professionals. However, the structure of the company also determines how the systems development team is set up. The other IT professionals include project managers, software development managers, etc. Limitations and challenges of traditional approach. Due to formal sequential pattern of the traditional method methodologies, users are expected to give out requirements at the early stages of the project. As a result, users may give out incorrect requirements or leave out critical requirements. These traditional methods are not most suitable for the development of projects, whereby system requirements change regularly. The development schedules have to be shortened because that has a negative impact on quality.
So, good day, classmates, especially to our respective teacher, Sir Denver Palmiano. My name is Farhana Micaela T. Francisco, and I am about to tackle my assigned topic, which is Iterative Approach. So, from the word iterative, what have you understood or what comes in your mind when hearing that word? So, iterative simply means repetition o paulit-ulit na proseso. The iterative model is also called an incremental model in which a particular project or software is broken down into large numbers of iterations. If you have a delivery in current scenario, for instance, the current dynamic scenario, the market conditions, you can't wait for delivering a software for like too long. Okay, so you have to deliver the value to the customers pretty quickly. And that is why you have to deliver software very quickly. And in order to address those issues of delivery or delayed delivery to the customer, iterative development model was introduced, where each iteration is a complete development loop resulting in a release of executable product or software. So if you are confused or familiar with the development loop, the development loop is a simple, easy-to-use app that tells the real story of foreign assistance by enabling users to add and edit their own project information. A subset of the final product under development which grows from iteration to iteration to become the final product or software. So meaning in order to build successful product or software, it will undergo muna with multiple iterations or ilang ulit na proseso till ma-meet lahat ng requirements in order the product will be modified as finished. The incremental build model is a method of software development where the product is designed, implemented, and tested incrementally. Incrementally means a little more is added each time until the product is finished. Meaning in every build phases, it will followed by multiple iteration o paulit-ulit na proseso. In every build or phases is nag-a-add ka, for instance, some features or functionality until the product or the software will be successful or finished. The product is defined as finished when it satisfies all of its requirements. An iterative lifecycle model does not start with a full specification of requirements. Instead, development begins specifying and implementing just part of the software, which is then reviewed to identify further requirements. This process is then repeated, producing a new version of the software at the end of each iteration of the model. Say for example, the first iteration you will pick certain things. For instance, you will try to build some of the initial features in the first iteration, right? Then you will pick another set of features on the second iteration. So second iteration will build another versions. For instance, the process will continue until the whole software is achieved. So on and so forth until it reached the third or more iteration. So for you to understand it clearly, I will give an example on how the software will be built incrementally or basically with the data development approach. So I have an example here, a picture. In the first iteration, for instance, we will build the sign-in page, right? On the sign-in page, we'll just have the email, the password, and the sign-in button. Those will be built in the first iteration. So all of these will be built, tested, and implemented. Okay, after that, for instance, you want to add more features or more functionalities. So the next, you will also add more feature to beautify the page, like a lot of features, and add some design to look more desirable. So this is how you will keep incrementally adding more functionality in both iteration in the iterative development model. First thing, that there will be the first phase and the second. As you can see, it is added with more features and functionalities. Like for instance, after those first iteration, including the email, password, and the sign-in button. In the next iteration, you added some different functionality. Say example, as you can see in the screen, the second iteration is now added. Hi Thomas, what would you like to do next? Na-apoy na dungag na search bar, favorites of filters sa second iterations. Then in the third iteration, you might pick more feature or functionality. Say for example, my results and kanang literal na iyang results jud. So on the second iteration, we usually do searching, no? So the possible outcome is mugos in results, obviously. So those features can come in third version of the software. In this incremental model, the whole requirement is divided into various builds. So as you can see, the build 1, 2, and 3, during iteration, the development module goes through requirements, development and design, testing, and implementation. Each subsequent release of the module adds function to the previous release. So meaning in every other version of the software that follows to the previous version adds functionality to it. The process continues till the complete system is ready as per the requirement. So I have an example here to connect it to our main topic for us to understand it clearly. So again, iteration is the process of repeating steps. For example, a very simple algorithm for eating breakfast cereal might consist of this step. Number 1, put cereal in a bowl. Add milk to cereal. 3, spoon cereal and milk into mouth. 4, repeat step 3 until all cereal and milk is eaten. Number 5, rinse bowl and spoon. Algorithm or problem-solving operations will repeat steps 3 and 4 until all the cereal and milk has been eaten. So, there are similarities in incremental model where you will add functionalities in order the product will slowly achieve, and there is also a repetition or iteration happening in that scenario to satisfy the requirement in order to achieve its goal, which to achieve the product or software. The key to a successful use of an iterative software development cycle is rigorous validation or streak of requirements and verification and testing each version of the software against those requirements within each cycle of the model. As the software evolves through successive cycles, tests must be repeated and extended to verify each version of the software.
Hello everyone, today I will be discussing about the end-user development approach. EUD is a set of methods, techniques, and tools that allow users of software systems who are acting as non-professional software developers at some point to create, modify, or extend a software artifact. EUD refers to systems in which non-programmers can create or modify working applications. Here are some of the examples of end-user development. First, we have the natural language programming, 3D model, mobile app development tool, spreadsheet. Spreadsheet is the most popular EUD tool because it is used to compute or to calculate complex data. So we have here web mashups. So a web mashup is a web application that uses content from more than one source to create a new service. And lastly, we have the virtual programming. Let's talk about the birth of end-user development. So, prior to the 1980s, most computing occurred on mainframes controlled by professional developers in information systems departments. End users had little influence over the form and function of software running on a mainframe, which they generally viewed through simple terminal windows and controlled with simple textual commands. Information systems departments rarely had enough staff time to design and implement all of the software enhancement requested by users. Professional software developers cannot directly meet all of these needs because of their limited domain knowledge and because of their development processes are too slow. And that's how they hire non-programmers to make the development process faster in order to meet those demands. So next we have the End User Development Software Engineering, or EUSE. It is defined as end user programming involving systematic and disciplined activities that address software quality issues. So attention to quality is important for AUP because poorly written software can cause data loss, security breaches, financial loss, or even physical harm, even when the software is created by end-user developers. So the software qualities relevant to EUSE are the same as those of interest to professional developers who sell their products. So EUSE have a qualifications for software quality. So these qualities include reliability, performance, privacy and security, and maintainability. Here we have the end user development cycle. We have the investigation, identify basic requirements, build basic prototype, user review of prototype, refine and enhance the prototype, implementation, and support. Let's talk about the advantages and disadvantages of EUD. So first, it encourages active user participation, improves a requirement determination, strengthens user sense of ownership, increases speed of system development. So disadvantages are inadequate expertise leads to underdeveloped systems. Lack of organizational focus creates privatized system. Insufficient analysis and design leads to subpar systems. And lastly, lack of documentation of a system may lead to its being short-lived. Next, we have here the importance of including end user in the software buying decision. So first, end users have hands-on knowledge of the problems that need to be solved by the new software. Their expertise and proximity to the problems make them qualified to give suggestions for how to best fix those problems. Second, end users have experience with the previous software application. This experience translates into valuable knowledge regarding what works and what doesn't. If the previous solution had a feature that did order processing really well but couldn't print needed shipping labels, the best way to find this out is by talking to the people who know it. Third, end users can advise on which features are most needed by having intimate knowledge of the problems that need to be solved along with experience with comparable software. End users can provide with valuable input about what functions the new software should be able to perform. So all in all, end users are very important. You can ask for their suggestions about buying a new software because they spend most of their time by using a software because that's their job, and that they can compare which software is the best. And if you need to know whether resource scheduling or deadline tracking is more important, you can ask these people. I guess that's pretty much it from this lesson. This is the end of this slide. So I hope you have learned something from my discussion about the end-user development approach. So thank you for watching and bye!